Hello and welcome to this series of lectures on GraalVM, Java Native Image. This is one of the exciting topics for me personally because that allows you to write your Java application, develop it very quickly. Developing a Java application is much faster than developing, for example, a C++ application. And then with the press of one button, you compile your Java application to an executable native binary of your platform, like 64-bit, CPU architecture and macOS or Windows and Linux, right? So it's very exciting. You get all the benefits of the Java, all the benefits that the Java programming provides, and then eventually your runtime becomes as fast as a C++ program because you compile to native binary. Now there are some pros and cons. Obviously the pros for me personally are much better than the cons. One of the cons you probably can guess if you're familiar with how Java works is that Java emphasizes on the dynamic compilation of your program, which means when you launch your Java application, the JVM or the Java virtual machine runs in an interpreted mode, which means each line of code gets executed one by one, right? And then after a while, the JVM, the runtime analyzes your code, how it behaves, and which methods are called more often than others. And if some methods, really the call to some methods passes a particular threshold, which you can configure at runtime when you launch your JVM, then that method, that particular piece of code gets compiled to the native binary, which is optimized for your platform. Whereas in this case, we're trying to directly compile your Java application to a native executable, which means we don't get the benefit of dynamic compilation. So all the compilation, all the analysis of the code appears at compile time instead of at runtime. So this means you end up with something called a static compilation instead of dynamic compilation. So I'm going to write it down here. It's more like a static compilation of your code. And then what happens then is that you know that Java provides some dynamic class loading, Java reflection, which means introspecting your classes, objects at runtime. So then the question is, usually this kind of stuff like reflection, they're not very compatible with static compilation because they rely on some sort of extra meta information at runtime. That's why the JVM, when you launch your Java application on the JVM, it has a particular piece of memory called the meta space, which is reserved for basically storing information, meta information about your classes and objects so that you can retrospect or basically use the reflection to see what properties a class has or not, right? But again, we will see that GraalVM at the current point of time, it's reached a very good maturity with the release of Java 17, which was a long time support, LTS support. They also released a GraalVM version that supports Java 17, and in this course I'm going to basically focus on the native image tool that comes with the GraalVM for Java 17. I've tested it, it's really working fine. We will look at all the details, how to compile your Java application, for example, if it has dependencies on some other jar files, on some other libraries. What if you have dependency? What if your application actually uses Java Reflection API? Is it supported or not? What if you're using Java native interface? Your classes have some native methods. I will show you how to basically do that. Eventually, the goal is we're going to write our Java application, develop our application in Java instead of C++. And then we don't worry about memory management, whether or not use raw pointers, smart pointers. Java doesn't have any of those concepts. And you can kind of guess what happens with this kind of static compilation is that the way the GraalVM works in a general sense is that they provide something called SVM, subsystem VM or subsystem virtual machine. It's a dense version of the JVM, Java virtual machine. And what they do is that not only they compile your application to the native binary, it also provides a dense or compact compilation of the, for example, the garbage collector that comes with the JVM, and then, or for example, the JVM itself, it has components like class loaders, right? So everything gets compiled, and the sub VM, the SVM, provides that infrastructure so that eventually your code gets compiled. One drawback you will see that is if you write the same application in C++ and in Java, right? In C++, you directly write your application, compile it to the executable binary. In Java, you write your application and then compile it with native image, and it creates an executable binary. You will see that the difference in the size of the files. In C++, executable is very small, right? It could be just a few kilobytes. But in Java, when you use the native image, it becomes, let's say, at least 10 megabytes or so. Now, obviously, 10 megabytes these days is basically nothing. So compiling your application to native binary is very well worth it, right? 10 megabytes compared to a few kilobytes. Both of them are still very much acceptable, right? And the reason for Java native image, the reason it becomes large is because not only it has to compile your application, it has to provide the infrastructure, which is the JVM itself in the executable binary, the garbage collector, the class loaders, all this stuff, right? But one thing that we will see is that once you compile your application to native image, the startup of your application becomes very fast. Why? Because now there is really we know that when you launch your JVM, there is a warm-up period. When you launch your JVM has to first load all the class files that come by default with a JDK, right? Because your application might depend on them. So JVM has to load all those class files into memory. That takes time. That's why sometimes people say that the JVM has a slow startup time. And then obviously the next step is warm-up time, whether or not the dynamic compilation happens or not. So in general, a static compilation allows your application to start up much faster. And in the course of these lectures, I'm going to focus on developing command line applications, which means you write your Java classes. The entry point to your Java application is the main method of a class. And then that main method accepts some arguments, and a string array of args. And then those are the command line parameters that you pass to your application when you launch your application. So we will see that when you compile to native executable binary, those command line arguments become very useful. Now they are the way that you interact or pass parameters to your native executable binary. Now let's start with, first of all, how do we run a normal Java application? Now obviously, in order to develop a Java application, you have to write source files and then compile them to the class files. Class files are basically a compact version of your source file. Those are the binaries that the Java virtual machine understands. And converting in order to do that, first you have to get a development kit or Java development kit, right? So this is different from Java runtime. Java runtime is basically the Java virtual machine. So Java virtual machine is the runtime, which means once you develop your application, now you want to run it. In order to run it, you have to load those class files into memory, because class files are the blueprint of how you're organizing the data, right? So you're going to need a JDK or Java development kit. And then right now, I recommend you download JDK 17. I believe Java 18 was also released, but it's not a long-term support. So it's best to develop your application, especially if it's a large application with a long-time support versions, right? So JDK 17 is an LTS version. And then you can use it. And I believe they changed the licensing also, so that from JDK 17 you can in fact use it in your commercial production. But the goal of these lectures that I'm presenting are not about commercial use. It's just for spreading the knowledge of Java. All right, so first you need a JDK, and then the JDK Java development kit comes with some applications. And those applications are called command line binaries or executable binaries. So on Mac OS, here's a screenshot. You install the JDK, you get a folder JDK, some version 17, and inside that there is a folder called contents and then home. This folder home is usually referred to as the Java home. And inside the home directory, there's always a bin directory. Bin means binary, which means there are command line applications that are the form of binary. These are executable files, all right? And then You see there are a lot of command line tools or executable binaries that come with JDK. They allow you to, Java C is the Java compiler. It allows you to compile your source file, which is a .java file, into a class file, which is what your JVM or runtime understands. And then we also have the Java virtual machine or Java command line. And this is basically what actually loads your class files into memory and launches your Java application. I will show you an example of how to actually write a class that has a main method, and then how to launch your Java application using this binary, executable binary, which is Java. So if you want to launch your Java application, you have to have an entry point. So again, if you're familiar with Java, you know that you can develop your Java application in two ways. One is an application that has a main method, which means it's an executable application, you can run it, or you package your project into a library. It acts as a library. It just has it's a basically collection of class files that are just that act as a library. So you add them to other projects and you build upon them, right? And as you can see in the bin directory, there is a executable binary called jar. Jar means it allows you to basically package your library as an archive file, which is a compressed version. It has only the class files. It usually doesn't include the source files. And then a jar stands for Java archive, which means is a compressed version. So Java archive or jar file is a format of the zip file. So it's very compressed. The size is very small. And we know that the Java is platform independence. That's why you can use jar file on one platform to another. And that's a very nice benefit on Java, right? And by the way, when you use a static compilation and compile your Java application to a native executable, obviously these executables are not compatible on different platforms, which means if you compile for the Mac OS, you cannot run it on Windows. That's why I'm going to have separate lectures on how to compile your application on Mac OS, how to set up your tools in Windows, and then compile your Java application to the native binary in Windows. Same with Linux. Mac OS and Linux are much easier to deal with because they have a much nicer terminal interface. Windows is a little bit tricky. You have to do more work, but I will show you how to automate the process. All right. So you can launch your Java application if you want to build a basically executable Java application. And the entry point is the main method of a class. And we know that the main method is a static method, which means the JVM has to be able to access and run this method without even instantiating an object of your class. That's the meaning of a static method, right? And then the way you compile your source file or basically the way you compile your source file into a class file so that you'll be able to load them into JVM and launch your application is using the Java compiler. And then the way you launch your Java application is with this command line. So you have the Java binary tool that comes with your JDK. -cp means class path. You have to provide the directories that include all the classes necessary for your application to perform. If your classes have dependencies on other classes, you have to provide all these into a variable called class path. And therefore the JVM is basically is aware of which directories to search if it needs to load a particular type, because each type, when the Java compiler compiles your source files, each type gets compiled to a separate class file. And those are the blueprints for the JVM to understand what you're talking about. And then you have to specify the main method of a class, or basically the fully qualified name of a class that has a main method, right? And then the Java JVM looks at this class, searches in the class path in these directories to see if it can find a class file that has this name. If it does, JVM looks at it to see if it has a main method. If it does, then it starts by running that main method and then continuing executing all the lines of code in the main method of your class. So you see in the binary folder of the JDK 17, there are lots of different binaries. One of them, for example, JDB is Java debugger. It helps you debug your code. JDepper scan, it it scans your application to see if it uses any deprecated API. JDEPs, it also scans your application, tells you whether you're using, what kind of modules you're using, because from Java 9, JDK became modular, so they introduced the module system. So if you want to see what kind of dependencies you have, JFR, Java Flight Recorder, it's more like inspecting the internals of the JVM to see what happens when your application launches. Obviously, when you compile to native executable binary, you don't have any of this, right? There is no concept of the JVM or runtime. It's just binaries, operating system executes them, and then that binary only contains CPU instructions, right? That's how you compile to native binaries. JPackage allows you to kind of package your Java applications in a nicer format. JShell is an interactive shell that they introduced from JDK 9, and it's more like a REPL, read, print, evaluate, something like that. And then there are lots of other things. I will have separate lectures to go into the depth about each one of these tools and how to use them. In this series of lectures, we're going to just look at Java. And again, at some point, we will switch to an IDE, and IDEs hide a lot of the details of the compilation, organizing your codes, class path, etc. So you don't need to worry about things. But right now, I'm showing you this is JDK 17. In order to get the native image tool, we have to download the GraalVM, which it also provides all the tools that come with the JDK, right? Jar, Java, Java-C. But GraalVM comes with additional tools like the SubVM, SVM, and the native image tool. So GraalVM is a separate thing that we need to download. Now, what happens when you launch your JVM or Java application through the Java binary tool, which means you are creating a virtual machine, a runtime, and then that runtime already manages the memory and then how to allocate, deallocate object, etc. So you don't worry about those. In the step 1, JVM first loads all the JRE class files. These are the basically the API, the Java API that comes with the JDK. So I'm going to type here JDK API, right? These are, and the reason the JVM has to load all these into memory because your application may use any of the classes that are in the API. So JVM has to load all of them into memory. And that's why some people say that the JVM has a slow startup time. Obviously, in the recent releases, with every release of JDK, they improve the performance of the Java or the JVM, Java Virtual Machine. So the startup becomes faster, the classes become more compact, they have less footprint, the JVM it consumes much less memory. And we will see that when you compile your Java application to native executable binary, the memory footprint becomes significantly smaller, which means now your your Java application in the format of the native binary consumes much less memory. That's another complaint that people usually have when compare, for example, C++ applications to Java application. They usually say that Java applications are a memory consumer, which means Java applications consume much memory than an equivalent C++. But that's the way that, with the memory, you can always configure your JVM. So when the JVM loads the class files from JDK into memory, JVM compiles some of the JRE classes. So it's not just loading them into memory. JVM has tiers of compilation, and because obviously loading them and then executing all of these JDK APIs, the classes in the interpreted mode is not very efficient. That's why JVM, as soon as it loads them into memory, it also tries to compile a few of them. Not in a full optimized way, but in one of the tiers of compilation, so that it's easier to work with, it's faster. And clearly, these compilations and loading of all these JDK API takes time, hence a slow startup time. I'm going to put the slow in the double quotes, which means it depends on which version of the JDK you use, right? So the newer version of the JDKs, everything improves, the performance improves, the application becomes faster. So once the JVM is done with all the JDK classes, and then it just reaches your application class files. So JVM loads them, let's say the class file from your application that has the main method, and then launches it. It starts executing all the codes in the main method, and after a while, the JVM profiles your application. So JVM comes with a profiler that looks at your code and see which parts of the code are executed or called more frequently than another. And if there is a threshold and some pieces of the code in your application pass that threshold, then the JIT compiler, Java just-in-time compiler, which is basically dynamic compilation, may compile some of the classes. And there is a flag actually at runtime that you can pass to your JVM that shows which methods are getting compiled. So this still also takes time, right? This is called dynamic compilation, and it takes time. This depends on how long the application is running. So again, it goes into the warm-up period of your application, because the JVM profiler has to look at your code for some time, right, to decide which parts of the code are being executed more frequently, and therefore to decide whether or not to compile them to a native executable. But then we say that, okay, so this is great. Java is great because its API is much easier than C++. You don't need to worry about memory management, any of those. But then the problem is the slow startup time, and then one way to solve that is to compile your application to a native binary. And that completely solves the slow startup time, because everything has been already compiled. There is no extra compilation at runtime. Everything has already been compiled to native binary. You just launch your application after it's been compiled, and then the operating system and the hardware just runs your code, right? So this is called a static compilation. And I hope in these series of lectures you learn very well how to do this. So I hope you enjoyed this lecture. Please stay tuned. I'll see you in the next one.